Good afternoon, everybody. My name's Alon Bartour. I'm a product manager at Trifacta, and I'm here today with my colleagues Jingshu Chen, who's a user experience designer, and Joe McKinney, who's one of our software engineers. We're going to be talking a bit about our experience building data products for users with different backgrounds and skill levels. We're each going to talk about our perspectives, so I'll start out with some background and context and a little bit about who our users are, and then Jingshu is going to discuss the design process for how we design for these different groups of users, and then Joe's going to finish it up with a demo and then a discussion on how he's implemented some of these concepts. How do I go forward? Oh, can we go back one? Great. So just a little bit of background for any of you who don't know what Trifacta does or who we are. The company was founded in 2012 off of research, collaborative research between Berkeley and Stanford that brought you Data Wrangler. And ever since then, we've been working with our users to better understand their use cases and iterate on some of those early concepts. What we're doing is we're building products to help solve the human challenges of data wrangling. So that's understanding, discovering, and transforming data so that it can be used by other systems and people. Today, we're going to be focused primarily on transformation. So I would be remiss if I started a Trifacta talk without mentioning the fact that data is messy. So it doesn't matter whether you're dealing with system logs or JSON scraped from an API or public data like this election results that are kind of complex and very difficult to work with. You very frequently don't have a say on how the data that you're forced to work with is structured. Added to that is the fact that most organizations only have few people that can take these disparate and complicated systems of data and turn them into something orderly that can be consumed downstream. And these few individuals usually sit in different lines of business and in different groups and have different goals and objectives to the people that are trying to ask questions of the data. On top of that, the process is slow. So in some of the early data wrangler research, the figure we kept hearing was that 80% of an analytics project is spent just preparing data, not actually doing the analysis itself. So it becomes super critical that we enable the users who know the data best to get their hands on it and really solve the problem of self-service data wrangling so we can get around this human bottleneck. So before we go any further, I want to introduce the concept of predictive transformation. We're going to be referencing this throughout the talk, so I want to make sure that everyone has a baseline understanding of the concept. This is one of the primary ways that users will interact with Trifacta. And the way it works is a user will point out features that are interesting to them. So that could be selecting text. That could be pointing out columns that are interesting that they know they want to use. It could be selecting ranges in a histogram or pointing out mismatched types or missing data. As soon as the user's done that, the system will come back with a ranked list of suggested transformations. So it's going to come back with what it thinks the user wants to do. And then as the user browses those suggestions, they get a visual preview of what accepting any one of them would result in. So with that, the user is able to go through that iterative loop of telling the system what's interesting to them, and then having the system come back with those suggestions. So Joe's going to demo this a little bit later on to make the concept more concrete, but I just wanted to introduce it. So what this very approximate and abridged timeline is trying to show is that Hadoop has made great inroads in becoming more usable and more accessible over the years. So adding abstractions like Pig and Hive, interfaces like Q, resource managers like Yarn that enable technologies like Spark to run in Hadoop. All of these things have increased the reach and influence of Hadoop and have brought more users into the fold. The problem is that Hadoop at its core remains a very technical platform. And over the last couple of years, a lot of companies have launched applications on top of Hadoop that solve problems that are felt by users that historically may not have had to interact with it. So things like analytics and visualization and lineage and machine learning and data wrangling and governance. These are all problems that apply to business users as well, or non-technical users. And so this, again, is bringing more of these users into the Hadoop ecosystem. So before we originally launched Trifacta, we spent a lot of time talking to companies and people that were using Hadoop to get a better understanding about their backgrounds and what their needs were. And the two personas that we ran into most frequently are what I'm calling a data scientist and a data administrator here. Now, in the real world, they go by many different names and titles, but we kept running into these two profiles again and again in our conversations. The user that I'm calling a data scientist is someone who has access to Hadoop and who's smart and savvy enough to learn whatever tools and technologies they need to get what they want out of the platform. The person I'm calling a data administrator here is someone that knows Hadoop and is working with groups across the organization to provide data that they need. Oftentimes, they're working off of requirements of pretty vastly varying specificity, and they're working with these different lines of business to make sure that they have the data they need. Now, given where Hadoop was 3 years ago, one unsurprising common thread between these two users was that they were both technical. So what I'm showing here is a screenshot of an alpha version of Trifacta from back in 2013. And I want to walk through this as an example to show all of you where we came from and how we're going to start evolving, or how we have evolved, rather, the product since then. So in this particular example, what a user has done is selected one of the dates in column 3, which is the light turquoise highlight. And the system has come back with the list of suggestions at the bottom. And these suggestions are in a language called Wrangling. So this is Trifacta's domain-specific language for data transformation. And it's an abstraction on top of the lower level languages like Pig and Spark that we're actually using to run these transformations at scale. Now, for these early users of Trifacta, when the system got it wrong, or they needed to modify these transformations, or they wanted to author their own after they had learned Wrangle, what they would do is work with the transform editor. So the transform editor allowed them to specify transformations and edit current suggestions. And this was great for these early users of Hadoop, because what they could do is use Trifacta to drive suggestions and construct patterns and get around some of the tedious work of crafting transformations, but still retain the control and specificity that scripting provides. A further example of our technical initial focus can be seen if we focus in on the pattern specifically that we're suggesting as part of this transformation. So show of hands, how many people here are familiar with regular expressions? Right, that's what I thought, most of you. So most people that have written more than a couple lines of code, and many of you haven't, understand what regular expressions are. Now, the problem with regular expressions is even though they're a great way to define search patterns, they're pretty difficult to read and debug, even if you're the person that originally wrote them. So what we've done since then is build another abstraction on top of Wrangle, which is Trifacta's pattern language, to try to make this easier for users to use. So poll, another show of hands. Who here can tell me what this regular expression matches? OK. Now, how many people can tell me what this Trifacta pattern matches? So the point I'm trying to make is that when used judiciously, abstractions can be very powerful, even when the users understand the lower level concepts in play. So one of the things that we've noticed in the last couple of years since this alpha version of Trifacta is that there's been a dramatic uptick in the number of non-technical users that need access to data that's residing in Hadoop. So the user, or the persona that I'm calling a data analyst here, is someone who's probably comfortable with tools like Excel and Tableau, who knows what questions they want to ask of the data, but who often gets frustrated by the fact that they can't access the data or work with it in Hadoop. A lot of the users that we've worked with over the last couple of years fall into this group. And for them, presenting them with a scripting language, even a very high-level one, is overwhelming. So the current abstractions that we have aren't enough for this user, which led us to ask the question of what can we keep doing? What can we build on top of what we have today to make these users productive? So if I plot technical proficiency on one axis and the level of abstraction that a user is comfortable working with, I can throw some of the concepts that we've talked about along this line. So at the bottom, I have MapReduce, then some of the Hadoop abstractions like Pig and Hive, then our original Wrangle syntax, and then the new Wrangle syntax with patterns. But the question remains, what can we build up here that lets these non-technical users use Trifacta and use it productively? Before we answer that question, I want to point out that building a product for different groups of users with different backgrounds and skill sets and goals is tricky. And I'll use an example to illustrate that. Let's say I'm designing a food for two groups of people. One group is very health conscious. They love salads and vegetables and juices and things like that. The other has a sweet tooth, so they like desserts in all of their wonderful forms. Now, if I was naive, I might go talk to each group, find out attributes of the foods they like, and take those, and then design something that tries to embody them. The danger in doing that, the danger in just looking at what someone's asking for and not understanding where that needs comes from, is that it can result in a product that nobody likes. So the challenge we face at Trifacta is how do we avoid designing the vegetable-flavored Jell-O of data products? One final question that I'll pose before I hand it over to Jingshu is, if it's so hard to do this and it's so easy to get wrong, why try? Why not just build separate products for each of these groups of users, focused entirely on their needs? Well, the reason is, even though the users have different backgrounds and understand the problems differently, fundamentally they're doing the same task. So by building one single product, what you're doing is giving these two or multiple groups of users a common language that they all speak. And having that language makes it more easy for them to share concepts and communicate with one another. And we think that that's worthwhile. So with that, I'm going to hand it over to Jingshu, who's going to talk a bit about designing for these users. Oops, forgot the build. There you go.
Hey, which one?
Just that goes forward.
Okay. Hi, everyone. I'm Jingshu Chen. I'm a user experience designer in Trifacta, and I'm going to talk about our design process for improving the user experience for multiple personas. So to design great experience for such a broad spectrum of users, we started our design exploration from the two extremes, the non-technical people who don't know how to coding and scripting at all. By the way, I don't mean non-technical people look like this, no offense at all. And super technical guys who live in code every day. So you might ask, why don't we start from the middle? Like start from making the average user happy. While this approach might make sense for some cases, it doesn't really work when the spectrum of users is so broad and the variety of their skill sets is very huge. Because if we tailor the design for the average user, as people move away from that middle point, the usability for them will drop hugely. And once people don't fall into that middle range, the design will simply doesn't work for them, similar to that vegetable Jell-O example Alon brought up before. So we don't want to design vegetable Jell-O as our data product. That's why we start from the extreme. Actually, engaging with extreme user gave us a lot of great inspiration and insights, because the needs and pain points of these extreme groups of users are usually more amplified than normal people. So they help us to pull a lot of meaningful insight that might not pop up in the conversation with average users. And more importantly, the insights come from these extreme users usually apply to a wider population too. So by starting from extreme user, we get a full picture of this spectrum. And we believe if we can make a product that extreme users love, it's more likely that we'll design a product that works for everyone. So before we dive into the design details, we need to understand our user, like what tools they use every day and what interfaces they interact with, and also what input devices they feel comfortable with. And all these differences form their different mental model and perception. So usually, in non-technical people, they prefer to just look at the end results, and they don't want to dealing with too much of the details behind that thing, while a super technical user usually tend to code everything, craft everything in code by themselves. But these perceptions are based on their current tools, the existing tools, which doesn't have to be true. Wouldn't it be great if a non-technical user can have more control of the end results in a way that doesn't feel like coding or scripting? And what if we can help our super technical users to accomplish their task in 20 seconds, not 2 minutes, just with a little help of some smart algorithm? Because although they are different, they use different tools, they think differently about the things they are doing, they are actually fundamentally doing the same thing, that is transforming data. So how might we empower our user to transform data in a way that matches their mental model? And after a lot of design exploration and iteration, we come up with something interesting. So for non-technical user, we designed this visual transform card. It is a visual representation of our transform. So instead of showing user a list of suggestions like this and require them to understand Wrangling language, we present our suggestion in a much more visual way. So in each of these cards, there is a mini preview of the results of that transform. By looking at these transform cards, people can easily get an idea of what each suggestion does, even if they don't fully understand the Wrangling language. And for technical user, we designed an IDE mode of our script. So typing in this single line transform editor might feel limited to a lot of super technical guys. So script IDE mode provides them a much more flexible way to create their script. They can use whatever indent style they like and also comment out certain parts of the script. And in the meanwhile, they still get the preview of their data on the left side and also other useful visualizations like histograms and quality bars. And whenever they need, they can still use predictive transformation to help them generate parts of the script and also, for example, like some complex regex. So with cards and the IDE mode of script, we are able to improve the experience for the extreme users. But we don't want to just stop here. We really want to bridge the two extremes and create seamless experience in Trifecta and make everyone happy. Because usually users are not static on this spectrum. They shift and changes constantly. For example, a super technical user, if he doesn't use the product for a while, he might become less familiar with the language. And as non-technical users engage more and more with the product, they become more technical. Actually, in our user study, we find out a lot of non-technical users, they do want to learn coding and become more technical. So we build more things to help users learn about Wrangling and really empower them. And we're going to demo predictive transformation later. So for now, I'll just focus on transform builder and the progressive disclosure of our script as examples of how we bridge the experience. So our predictive transformation is great, but there will be some cases where users want to tweak the suggestion a little bit or create their own transform. And transform builder provides a way for users to create transform without typing a lot of code. So the transform builder will provide a template for each verb and surfacing what parameters are required, and if there's any other optional parameters. So user only need to type in the value for each parameter. And also the transform builder provides specific suggestion for each parameter and inline documentation to help user learn about the language. Another design example is the progressive disclosure of script. So when a user first starts to engage with Trifecta and when they are not so familiar with Wrangling language, they can just engage with the mini version of the script. In the mini version, only the verb of each transform shows up. User can still click on them and to go back and forth in the script and see what each step does, but they don't need to look into the details of each step. And as they get more familiar with the system and the language, they can open the full version of the script. In the full version of script, they will get all the details they need to know about each transform. And they will also be able to delete or edit certain steps. And once they get super technical and super comfortable with the language, they can switch to IDE mode. And all these three levels of scripts are on the same interface. They are just three different states of the same UI component. So user can easily toggle between these three states of the script and choose whichever level they feel comfortable to work with. So now let's look at this picture again. With builder and cards, we're able to move up to that upper left corner and build higher level of abstraction for less technical users. And with that, I'll hand it to Joe McKinney to talk about how we implement these concepts. button, and this goes back.
Cool.
To switch.
Can you hear me?
Okay.
Okay, good. So we are Jingshu talk about designing these components for differing levels of technical proficiency. As a developer at Trifacta, I'm often tasked with building these visualizations. So how do I go about this? What do I think about? And typically my chief concern is keeping the experiences and interactions consistent across these levels of abstraction. It's important if we want to empower our users to move along this spectrum easily. So that's a major concern. And it's made a bit simple with the idea of predictive transformation. So the system is predicting different pieces of information at different levels of abstraction. So if we look at the slide, in the Wrangle DSL with type ahead, we're predicting, or we're helping you understand the parameters to transforms as well as the types expected for their values. One level up, a bit more constrained in the transform builder, we're giving you suggestions per parameter, a different approach, but helping you understand how to build the parameters for a specific verb. And at the highest level, coming at it from a completely different angle, we're explaining to you how the transform works based on the output of that transform. But we're still displaying some language, specifically the pattern parameters, in hopes that you can kind of tie back how different pattern parameters are affecting the output. And allowing the users, again, to move seamlessly between these different components. Cool. So predictive transformation, tying these concepts together. So let's see some of these concepts in action. Let's do some demoing.
I'll switch it over.
In a second.
Just squashing it. That's fine.
Cool. Good to roll. OK, so I'm Joe, technical user here, and I'm set out to understand a bit more about this data, clean it up a bit. So it's some mobile tracking data we have here. So poking around a bit, see we have some days and times of the day information, email information. And this screen detail column seems of particular interest. I see some query parameters in there. So maybe I'm going to set out to understand more about the query parameters and gain some information about that. I have my script here telling me the steps that have already been applied to the transforms that have already been applied. So I can kind of move back and forth and understand what the data originally looked like and how I got here. Easy enough. And then my editor, as both Jingshu and Alon had pointed out. So I head over here to start transforming. And I see that my cursor changes. So from the script to the grid, I have a different type of cursor. And if we hover over some of the other visualizations, we'll see a bunch of different cursors. And these are kind of highlighting the different classes of interaction with our different visualizations and how the system will generate suggestions. So selecting text will generate a set of suggestions. Selecting charts will also generate, and column names. And this exists across different visualizations. So if we open up the column browser, we should expect to see the same cursors in the same types of interactions. Cool. So I'm interested in cleaning up this column, like I said. So I'm going to try to get rid of the empty values. I'm going to go up here to the quality bar and select those empty values. And we see we get our suggestions below the transform editor. It's great. It's giving me a keep, and I'm more interested in deleting those. So I'm going to click that. And the preview looks good, so I will accept. And because I'm technical, I'm kind of happy using the editor, right? So I'm going to break out the time column into day and then time, because I'm more interested in the day, I think. So split the column access time, and space will be easy. And that works as well. The preview looks good for what I'm going for. That's great. But if I'm not advanced Joe, and I'm less technically proficient Joe, maybe I'm less interested in the script and using the editor. So I want to hide the script away and have a more abstract representation of the script. I'm not so concerned with the parameters to the transforms as I am the number of steps and still being able to move back and forth and understand how I've kind of gotten to a different point in my data transformation. Similarly, I'm going to turn on cards as I again, don't want to use the editor as much, or if I can avoid it. So same concepts. I'm going to go select some text. So I'm going to select the ampersand in hope of splitting out the values in this column. And we're presented with the cards. So the cards, similar interactions to the suggestions below the editor. You can click a card to kind of push the preview to the grid. Cool. There we go. It's great. And then we have these dots within the card that allow you to hover and see the suggestion for the different suggestions for that verb. So in this case, we can kind of hover over a bunch of different ones and start to see the different previews for those suggestions. And the first one looked right for me for what I'm trying to do, so I'm going to add that as well. So now we've kind of broken this apart a little bit. And another interaction that I described earlier, clicking column names. Again, at a higher level of abstraction, as it's not so clear as to what I'm trying to do, I'm going to let the system help me out a bit. So access time, I don't want to drop it, and screen detail too. And we get a bunch of different options here, but I'm interested in the aggregate. And our preview comes up with our input columns and our output table, and we can add that and see that we've arrived at a table explaining to me for each promo that I've run, how many times I ran it on a specific day. So using the product with kind of two different personas in mind is becoming easier and easier with time as we add these different levels of abstraction and new visualizations. So switching back to slides. Cool. So going to talk a bit about cards. Some of the problems faced when we move from simpler visualizations to higher levels of abstraction. So in this case, when we had these suggestions below the transform editor, it's quite easy to render out an enumerated list of suggestions space. So when we started to think about how we could visualize it, we knew that we wanted to visualize the output of the transform applied to the table, but we figured it might be a bit expensive in terms of render and computation costs to just visualize the entire suggestion space. So in the end, we went with grouping by verbs. This allows us to preserve ranking of the suggestions in the sense that we are still seeing on each card the top ranked suggestion for that verb. And then again, you can still hover over the dots and click them to see the other suggestions for that verb. In this way, we're also still conveying the space to you and potentially conveying more of it depending on how small or large the pane that contained the editor was. So an example of how we kind of get around these issues. But it works, and it conveys quite a bit to you. Cool. So how do we improve upon predictive transformation? We've talked a bit about what it does for us and how it allows different types of users to work with their data more easily depending on their skill set. So we've seen this idea of interacting with data, the system suggesting some set of transforms, and then you kind of working with those transformations, deciding whether they make sense, inputting into the system again, so making further selections to enhance, canceling and saying that's not what I wanted, or accepting and continuing on and adding that to your script. So if we wanted to build upon this concept or go a bit deeper, perhaps it's not only that you enhance by making more interactions, but that you change the interactions you've already made. So we can start to think about the idea of improving how selections work. So this is coming from the concept of trying to lift some of the functionality that you get in the text editor, where you can kind of do whatever you want, right? You're typing the language, you have all the power. And we want to give you some of that power at higher levels of abstraction. So in the first picture, we see that when you hover over your original selections, you get some bars, and these bars are supposed to tell you that you can change the range of your selection. So you can imagine doing that in the language, but now we're kind of lifting that to here, making it easier for you to understand how to edit your selections and how that ties back to what the suggestion engine will pump out. In the second example, something quite powerful, the idea of negative selections. So a mechanism for the user to say, I want to train the engine on something like, or not like this. And then the third concept, which is extremely powerful and we don't yet have in the system, the idea of surfacing a full selection management UI or interface, which would allow you to manage all the selections you've made that are tied to your transformations in the same way that you manage your script. So allowing you to rearrange, edit, and disable selections, and again, understand how that relates to the suggestion space. Because seeing that is very powerful. I disable this, I change the order, and now these suggestions are different. So that's one concept in terms of how to improve predictive interaction. Yet another concept is lifting some of this to an even higher level and bringing it into the cards, where users are not going to have to concern themselves so much about editing a selection as they are going to say that I am interested in this transformation. This transformation is along the lines of what I want, but I'd like to see more like it. And that's relatively loose, but at this level, that's kind of what we're trying to enable and present to some degree, is that the user doesn't have to understand all the way down to like base level, right? They can operate at this level and still get a lot of power from the system. Yeah. So where are we going from here? We have lots of work ahead of us, lots of great ideas. Product design and development are all working together to put a lot of these in action, and some of them already exist, as we saw in the demo. So yeah, that's where we're going. Sorry.
Thanks, Joe. Great, so that's it. If any of what we talked about today seems interesting, we're hiring. Stop by our booth and come chat with us. So we're booth P04. We have our headquarters are in San Francisco, and we are opening a South Bay office very soon. So with that, we'll take any questions. And if you'd like to try Trifacta for yourself, you can sign up at trifacta.com/trial to get a trial copy and give it a shot. Thanks.
I've got a general question. I was wondering, did you explore fixed length files aside from all the examples you had were pretty much delimited?
Yeah, so the Wrangling language can take positional arguments. So you can have it split, say, at given positions versus on a pattern. So what we were showing was a delimited file, but it can work with fixed length fields as well.
Do you have any product telemetry built in? And do you have any intelligence coming out of it?
Sorry, what was it? Can you repeat the question?
Do you have any product telemetry, which is like the usage pattern or heat maps of usage?
Yeah, so there's usage tracking in the product, and we're actually, so the suggestion engine that's surfacing the suggestions is looking at past usage and what people selected when the suggestion engine got things wrong, and updating that model, so updating the probabilities that a given selection in a given context. So that means previous transforms that were run, the type of the column, the fingerprint of that column, what transform suggestions that should drive.
Do you have any intelligence coming out of it, like IT users, start as technical?
In terms of things, nothing that we've packaged up that we can share, but we're collecting all that information, so it's a good idea.
Okay, thank you.
How many records do you scan before you apply your technology?
Yep, great question. So right now, as Joe mentioned, all of the previews and transformations that are being authored are happening client side. So we're taking a small sample of the original data to actually let users interact with it and craft these transformations. Right now, it's rather small. It's about 500K to a megabyte of the data to author these. That can be the top K to get started. We're also taking a pass of the full data to pull a random sample. And we're doing some work right now to build an engine that should bump up what we can work on in the client to around the kind of 100 meg to gig range. We're still.
Is there any user control over that selection?
In terms of the size, right now.
The size, or even how to, well, it's all going to the random sampling. Do you do substrate sampling and stuff like that? Is there any?
Yeah, not yet. So right now it's just top K and random, but yeah, sampling on a particular column or looking for, unique values. Those are definitely on our roadmap.
Thank you.
Thanks.
Is this shared across an organization, or is it all single user?
Yeah, so great question. The question was, is this shared across an organization or is it just single user licenses? So the product that we're showing today is our Hadoop version. So there's going to be an instance of Trifacta usually running on an edge node wherever it can talk to the Hadoop cluster. And then you can sign up as many users as you want in the organization that are talking to that single instance of Trifacta.
is the learned behavior per user or like per license? So could you have a shared learned behavior across a team or a group of people, or is it just per user?
Yeah, right now it's broader, but things like per user suggestions and updating the model based on someone's behavior or the types of data that they work with, that their organization works with, is directions that we want to go in. Right now it's relatively basic. Great. Well, if there are no other questions, thank you very much. If you guys want to talk anymore, we'll be at booth P04 and we'll be up here for a little while.